Hello again. In this video we're going to look at section 2.1. We're going to be talking about ordered pairs in the coordinate system. We're going to learn the distance formula and the midpoint formula, and I'm going to show you how to graph an equation in two variables by plotting points. Here we go. As you probably already know, an ordered pair consists of two components written inside parentheses. We always have an x and a y. The x comes first, and this is going to tell us the horizontal distance from the origin. And the y comes second, and it's going to tell us the vertical distance from the origin. Of course, a positive x moves us to the right, negative x moves us to the left. Positive y moves us up, negative y moves us down. Here is a look at a coordinate system for us. This is a rectangular coordinate system. And we have our horizontal axis, which is the x-axis, and we have our vertical axis, which is the y-axis. The point in the middle where they cross is called the origin, and that point's coordinates are 0, 0. Now, in the top right quadrant, all the x's are positive and all the y's are positive, and so this is called quadrant 1. And then the quadrants are numbered counterclockwise from there. Of course, quadrant 1 is the favorite because that's where all the x's are positive and all the y's are positive. But after that, we go counterclockwise. A lot of people get that confused because they think that quadrant 1 ought to be the top left because we read top to bottom, left to right. But when you're talking about geometry, trigonometry, that type of thing, the coordinate system is labeled with the top right being the first, and we go counterclockwise. Now, we're about to learn the distance formula, but before we just throw the formula out there, I thought it would be helpful for you to think back to the Pythagorean theorem, which you probably remember from middle school, or at least you remember a little bit about it. If we want to find the distance, say from point P to point R, one thing we could do is draw a right triangle so that the distance that we're looking for is the hypotenuse of that triangle. We can always draw a horizontal side and then a vertical side, and we'll have ourselves a right triangle. So now the Pythagorean theorem, you know, is a squared plus b squared is c squared, where the a and the b are the vertical and horizontal sides, and the c is the hypotenuse, which would be this p to r side. Of course, A and B, it doesn't matter which one you label which. The only letter that matters is the C. It needs to be the hypotenuse. Now, A would be the length of the horizontal side, and we could just count tick marks here, but an easy thing to do would be to take the 8 and subtract -4, and we would see that that side is 12 units long. And we can do the same thing on B. We could count, but it would also be just as easy probably to say 3 minus -2 is 5. And so we see that's the length of the vertical side. Now let's plug that into our Pythagorean theorem, and we'll have a squared plus b squared is going to be 12 squared plus 5 squared, which is 144 plus 25, and that adds up to 169. Now 169 is equal to c squared. So to find the value of c, we would need to take the square root of both sides. Now you may remember that I made a big deal earlier about when you take the square root of both sides, make sure you insert the plus minus symbol. But when we're dealing with the coordinate system, we typically ignore the plus minus because we're talking about a distance, and distance is by definition positive. It's not possible for distance to be negative because, well, distance is an absolute value. It only indicates how far, not which direction. So we only consider the positive version. And so C is 13. And we just discovered the distance formula. So here is our official distance formula. For any 2 points, x1, y1 and x2, y2, we can find the distance between the points using this formula. Distance equals x2 minus x1 squared plus y2 minus y1 squared, and then square root of that total. Now think about how this matches the Pythagorean theorem that we used in the last slide. The x2 minus x1 would be the length of the horizontal side, and the y2 minus y1 would be the length of the vertical side. We square them to do the a squared plus b squared part of the theorem, and then we do the square root of the total so that we have the length of the hypotenuse at the end. Now, you do need to memorize this formula because you'll be using it over and over again, and depending on the testing situation that you're in, you might have a formula sheet, but you might not. So please do go ahead and memorize this formula. And I think if you're familiar enough with it, you won't really have to memorize it like you would memorize a poem or something. You'll just know it. Now here is our first example using the distance formula. We want to find the distance between -8, 4 and 3, -2. I think, especially starting out, it helps if you have a coordinate system to look at so you can see where the points are. -8, 4 would be 8 to the left and up 4. 3, -2 would be 3 to the right and down 2. And the distance we're trying to find is the distance from P to Q. Now what you need to do is imagine a horizontal and a vertical side here so that you sort of see the right triangle. Alright, now our 2 points we can call x1, y1 and x2, y2. And here's the formula just for reference. So what we want to do is find out how long the horizontal side is by doing x2 minus x1. Find out how long the vertical side is by doing y2 minus y1. Square each of those lengths, add them together, and then square root. Okay, so x2 minus x1 is going to be 3 minus -8, which I wrote as 3 plus 8. And then we square that, plus y2 minus y1. Now y2 was -2 and y1 was 4. So y2 minus y1. Now under the radical in the parentheses here, 3 plus 8 is 11. And so we'll have 11 squared. And -2 minus 4 is -6, and we'll have -6 squared. Now 11 squared is 121. 6 squared is 36, and when it's negative, even though it's negative, when we square it, we get a positive. 121 plus 36 is 157, and that is a prime number, so that radical will not simplify. Now here is one that you can go through on your own, so pause the video and give it a try, and then I'll go through it with you. Okay, here we go. The first thing I would do is draw myself a coordinate system, and I would plot these 2 points. -13, 1 is going to be 13 to the left and up 1. And -5, -7 is going to be 5 to the left and down 7. And now we want to find the distance between these 2 points. Let's remember what our formula looks like. x2 minus x1 squared plus y2 minus y1 squared, all under the radical. And let's label our 2 points. This is x1, y1, and this is x2, y2. And now we will plug into our formula. So the x2 minus x1 is going to be -13 minus -5. Of course, minus negative makes plus, so I'm writing -13 plus 5. And that's going to be squared. And then plus y2 minus y1 is going to be 1 minus -7, which I'll write as 1 plus 7, and that's going to be squared. Now -13 plus 5 is -8, and 1 plus 7 is +8, and of course -8 squared is +64, and +8 squared is +64. Now together they make 128, but why bother to do 128 when we can see here that what we have is 2 64s, and 64 is a perfect square. So the square root of 64 is 8, and the 8 comes out of the radical and the 2 stays in. This is what you call exact form. If you're working in MyLabs Plus and you notice that it says state your answer in exact form, what they mean is leave it in a radical form, a simplified radical. Don't go to decimal form, which would produce an irrational number, which is a decimal that never terminates, so you'd have to round at some point. But when we leave it in exact form, it's still perfect. Now we're going to switch gears and look at the midpoint formula. Whenever you use the midpoint formula, what you're trying to do is find the coordinates of the point that is in the middle of a line segment where P and Q are the two endpoints. All it is averaging the x values and averaging the y values. So you know how to find an average. You add two numbers together and divide by 2. And on the y's, we will add the two numbers together and divide by 2. So whenever you're finding the midpoint, it's different from the distance formula because you're not finding a number that's a length. You're finding a point that's got to have two coordinates, an x and a y. Now here's example 5 from the text, and this has two parts, so let's look at the first part. It says find the coordinates of the midpoint M of the line segment with endpoints 8, negative 4 and negative 6, 1. So the 8, negative 4 would be our x1, y1, and negative 6, 1 would be our x2, y2. And for the midpoint formula, all we need to do is average the x's, so we'll add the x's together and divide by 2. Then we'll add the y's together and divide by 2. 8 plus negative 6 is going to be positive 2. Negative 4 plus 1 is going to be negative 3. And of course 2 over 2 reduces. So we have 1, negative 3 halves. Now let's just check our work visually. So I'm going to draw us a little coordinate system. And we will plot 8, negative 4. That'll be right 8 and down 4. And we'll plot negative 6, 1. That'll be left 6 and up 1. And there is the segment that we're trying to find the midpoint of, and the midpoint should be at 1, negative 3 halves. That's right 1 and down 1 1/2, which should be about right there, and that does appear to be reasonably the middle of that line. And so that's the midpoint formula. And the thing you need to remember is that the midpoint formula gives you an answer that is an ordered pair. I don't know why a lot of people get that confused. And a lot of times when they're asked for the midpoint, they'll just give a number. But it can't be a number. The midpoint has to be an ordered pair. Okay, now we have part B of this example, and it says find the coordinates of the other endpoint of a segment with one endpoint at negative 6, 12 and the midpoint at 8, negative 2. Now this is a little different from before. Last time we were given two endpoints and we were asked to find the middle. This time we're given one endpoint and a middle, and we're asked to find the other endpoint. So we can do this in two pieces. First we'll find the x, then we'll find the y. So here's what we have. We know that to find the midpoint of the x coordinate, we should add the two x's together and divide by 2. So negative 6 plus our unknown x divided by 2 is supposed to equal 8 because that's the coordinate, that's the x coordinate of the midpoint. Now if we multiply both sides by 2, we find out that the 2's cancel and the right side becomes 16. So we have negative 6 plus x2 equals 16. Now let's add 6 to both sides and we'll have x2 equals 22. For the y, we'll do the same thing. We know that the average of 12 and the unknown y value should equal negative 2. So multiply both sides by 2, and we find out that 12 plus y2 is equal to negative 4. Now subtract 12 from both sides, and y2 is negative 4 minus 12, which is negative 16. So the other endpoint is 22, negative 16. Now let's see if a diagram makes sense. And I had to draw it a little bigger to accommodate the 22 and the negative 16. And even so, I'm still counting by 2's here. So each of these tick marks represents a 2. If we plot negative 6, 12, I'll go 6 to the right. That's going to be 2, 4, 6, and up 12. 2, 4, 6, 8, 10, 12. That's going to put us right here. And if I go 22, negative 16, that's going to take me 22 to the right, down 16. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then down 16, 2, 4, 6, 8, 10, 12, 14, 16 will be about right here. Okay, now the midpoint that they gave us should be right in the middle, so 8 comma negative 2. We're going to go 2, 4, 6, 8, and then down 2, and that's going to put us about right there, which looks about like the middle. So that's reasonable, and I think we can say that we did it right. Here are a couple of exercises from the homework that are similar to the two we just did together, so I hope you'll pause the video and try these on your own. And now if you've had a chance to do that, I'll go through them with you. This one says, find the coordinates of the midpoint M of the line segment with endpoints -5, -7 and -13, 1. Well, we know that the midpoint formula simply asks us to average the x's and average the y's. So the average of the x coordinates is going to be -5 plus -13 all over 2. And the average of the y coordinates is going to be -7 plus 1 all over 2. Okay, now -5 plus -13 is -18. And we'll have -18 over 2. Then -7 plus 1 is -6, so we'll have -6 over 2. These simplify to -9 and -3. Now what you really ought to do, just to be sure that you didn't make some silly calculation error, is plot the 2 points and see if your midpoint really does fall in the middle of the line. So let's just quickly draw a coordinate system, and we'll plot -5, -7 here, and -13, 1 here, and we'll join those with a line segment. And now -9, -3 would fall about here. And so we see that that really is pretty close to the middle of our line. And if I had done this on graph paper instead of a hand-drawn graph, we probably would have even gotten a little better results. Now on this second exercise, they've given us the midpoint of a line segment, and they've given us one of the endpoints, and they've asked us to find the missing endpoint. Now remember that the x-coordinate of the midpoint is just the average of the two x-coordinates of the endpoints. And the y-coordinate of the midpoint is just the average of the two y-coordinates of the endpoints. So let's set up two calculations, one for the x's and one for the y's. So I'm going to call this x1 and y1 so that my missing numbers are x2 and y2. And I'm going to write x2 plus 13 all divided by 2 is equal to 5. And then I'm going to write y2 plus 10 all divided by 2 is 8. And so you see what we have here is the average of the x's and the average of the y's. Now on the x's, multiply both sides by 2. Here the 2's will cancel, and we'll get x2 plus 13 is equal to 10. And subtract 13 from both sides, and x2 is equal to -3. Now let's do the y's. If we multiply the y's by 2, the 2's will cancel out, and we'll have y2 plus 10 equals 16. And then we'll subtract 10 from both sides, and that will give us y2 equals 6. And now our endpoint is -3, 6. And let's plot just to make sure that that answer makes sense. So here is our 13, 10, and here is our -3, 6. We'll join those with a line segment, and now we hope that our midpoint of 5, 8 falls in the center of the line. So let's see, 5, 8 would be about right there, and that looks like the center of the line, so I'd say we did that one correctly. Now we're going to switch gears just a little bit. In this example it says for each equation find at least 3 ordered pairs that are solutions. See, a solution to an equation is any ordered pair that makes the equation true. So these equations have multiple ordered pairs that will make them true. And to find one of those ordered pairs, all you need to do is choose an x, plug it in and calculate y, and that will be your solution. So I'm going to make myself a table here, and I'm just going to choose 3 x's. You want to pick numbers that are small and easy to calculate with. So 0 is always a good choice. And how about 1 and also 2? And now let's plug in 0. 4 times 0 minus 1 would be 0 minus 1, which is negative 1. And now let's plug in 1. 4 times 1 minus 1 would be 4 minus 1, which is 3. And now let's plug in 2. 4 times 2 minus 1 would be 7. Now, our ordered pairs that we found are 0, negative 1, and 1, 3, and 2, 7. And now remember where these x values came from? We made these up ourselves. We get to choose the x values. Now let's try part B. Notice that part B is solved for x, so we'll actually be plugging in a y and calculating an x. Okay, so let's make a table. This time we're choosing y, and since y minus 1 is under a radical, I would like to choose y values that are going to give me perfect squares. Okay, I know that 1 minus 1 is 0, so 1 would be a good value to use. I know that 5 minus 1 is 4, and I know that 4 is a perfect square, so I'll choose 5. And also 10 minus 1 is 9, and that's a perfect square, so I'll choose 10. Remember, we choose these values based on what's convenient for us. And so I did not want to choose a y equal to, say, 7, because 7 minus 1 is 6, and the square root of 6 would have been a decimal. I don't want to have to deal with decimals if I don't have to. So I'm choosing 1 and 5 and 10. Now, let's go ahead and do it. 1 minus 1 is 0, and the square root of 0 is 0. And plug in your 5. 5 minus 1 is 4, and the square root of 4 is 2. And now plug in 10. 10 minus 1 is 9, and the square root of 9 is 3. So our 3 ordered pairs are 0, 1, 2, 5, and 3, 10. And here's part C of example 7. Again, find 3 ordered pairs that are solutions. This time we'll find a few more because this has x squared. So I think it's important for us to see what happens when x is negative. So I'm actually going to choose several x's for us this time. If we plug in negative 2, negative 2 squared makes positive 4, and 4 minus 4 is 0. If we plug in negative 1 squared is positive 1, and 1 minus 4 is negative 3. If we plug in 0, 0 squared is 0, minus 4 gives us negative 4. If we plug in 1 squared is 1, minus 4 gives us negative 3 again. And if we plug in 2, 2 squared is 4, and 4 minus 4 is 0 again. And so we have 5 ordered pairs for this one. We have negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. Here are some guidelines for graphing an equation by point plotting. This is not always the easiest way to graph an equation, but anytime you don't know the easy way, this way will always work if you need to somehow figure out what the graph looks like. Step 1 is to find the intercepts. Okay, we haven't officially talked about intercepts yet, so what are intercepts? An intercept is where a graph crosses an axis. To find the y-intercept, you'll always plug in 0 for x, and to find the x-intercept, you'll always plug in 0 for y. See, whichever intercept you want to find, plug in 0 for the other variable and solve. And then step 2, find as many additional ordered pairs as needed. How many is that? Well, it kind of depends on experience, and you'll get a feel for it the more you do it. Step 3, plot the ordered pairs from steps 1 and 2, and then join the points from step 3 with a smooth line or curve. And that's about it when you're just trying to guess at what the shape of a graph looks like. So let's try graphing the equation y equals 4x minus 1. Now you may already know how to do this the easy way from a previous algebra course, but right now we officially don't know that easier way. So we're going to use the guidelines for graphing an equation by plotting points. Okay, so first the intercepts. If we want to find the y-intercept, we let x equal 0. So with x equal to 0, we find out that y is negative 1. If we want to find the x-intercept, we let y equal 0. And so I'll put a 0 here and solve the equation, and I find out x is 1/4. So right now we have 2 points on our graph, and let's go ahead and get a couple of additional points. I chose 0, 1, and 2. Really didn't need to do 0 because we already had calculated what happens when x is 0. But if you plug 1 into our equation, 4 times 1 is 4, and 4 minus 1 is 3. And if you plug 2 in, 4 times 2 is 8, and 8 minus 1 is 7. So now we have not only where the graph crosses the x and y axes, but we also have a couple of additional points. And let's go ahead and plot these. 0, negative 1. Here is 1, 3, and 2, 7. And you see that I did not even attempt to plot the 1/4, 0, because 1/4 being a fraction, it's hard for me to tell exactly where that is. But when I connect the dots with a smooth line, I can easily believe that that point there is where x equals 1/4. So I feel like our graph represents our equation. Here's part B of example A, and this one asks us to graph the equation x equals square root of y minus 1. Now if you'll remember, we saw this one in a previous example, so let's start out by finding the intercepts. If we let x equal 0, we'll find the y-intercept, so I'll put 0 here. That will give us 0 equals square root of y minus 1. Let's get rid of the radical by squaring both sides. That will give us 0 equals y minus 1, because of course 0 squared is 0. And now let's add 1 to both sides, and we find out that the y-intercept is y equals 1. Okay, now let's find the x-intercept by letting y equal 0. If we let y equal 0, we get x equals square root of 0 minus 1, and that's a problem because 0 minus 1 is negative 1, and the square root of negative 1 is the imaginary number. So of course that's not going to appear on the graph. So what we just found out is this graph is never going to cross the x-axis. Okay, now the additional ordered pairs we calculated on a previous slide, so I've just copied them here. And let's go ahead and plot our points. We have the y-intercept, which we found out was 0, 1. We know the graph is not going to cross the x-axis. And now let's plot these other ordered pairs. 2, 5 is here, and 3, 10 is here. And so it's going to kind of curve like that. And that's the graph we're looking for. And our last equation to graph in this section, y equals x squared minus 4. Let's try to find the intercepts first. If we let x equal 0, we'll find the y-intercept. So when x equals 0, we get 0 squared minus 4, which is negative 4. The graph is going to cross the y-axis at y equals negative 4. Now let's get the x-intercept, so we'll let y equal 0. If I put 0 here, now I have a quadratic equation to solve. Notice that this is a perfect time to use our square root property, so I'm going to bring the 4 to the other side, and I'll have 4 equals x squared. Now I'll do the square root of both sides, and of course when I do the square root of both sides I have to remember to insert the plus minus symbol, and now we know that x equals plus or minus square root of 4, which means x equals plus or minus 2. So the graph is going to cross the x-axis at 2 places, at positive 2 and at negative 2. Now our additional ordered pairs that we had already calculated, now let's try to plot these. First of all, our y-intercept is negative 4, and our two x-intercepts are negative 2 and positive 2. And now I've already plotted this one, but let's do negative 1, negative 3, and positive 1, negative 3, and we'll connect those with a smooth curve, and that is the graph of a parabola.